Hi, I'm William Malik, Vice President of Infrastructure Strategies with Trend Micro, and I'm here to speak to you for the next 20 or so minutes about VicOne and what we're doing in the area of automotive cybersecurity. In the course of this presentation, we're going to take a look at the kinds of things we expect to see over the next 3 to 5 years and beyond, the kinds of countermeasures that we believe ought to be introduced, and the consequences of doing or not doing those things. For a long time, the rate at which new errors were detected in the automotive infrastructure was very low. A few years ago, it began to spike up. CVE's common vulnerabilities and exposures track known problems, some of which are exploited right away, some of which are latent, but all of them are exposures. And just happening to track the ones where we have active exploitation, that's where the headlines are. But as a security professional, we know that the thing to do is to shut down the possibility of new attacks. And you do that by managing the open CVEs. Now, the forecast for 2022 is based simply on taking a look at what we've seen through the end of August and then extrapolating for the last third of the year. So it doesn't look like a very good number. And these things are not trivial. We're not talking about so-and-so's key fob was able to be taken. We're talking about things that have broader infrastructural implications. Here are three recent ones. We have a impact of Log4j into automotive environments. We have a Bluetooth problem with communication in a Snapdragon subsystem, and we have problems with incorrect length concerned buffers in the Zephyr functionality. These programs are used across multiple automotive environments, and they represent active threats that could be exploited. The way we find these is occasionally somebody will report one, but we've actually decided to bang the drum a bit. Trend Micro owns the zero-day initiative. And one of the things that we do is run a contest called PWN2OWN. And in the one in May of this year, we had a couple of individuals who were able to show a couple of unique bugs hacking into a Tesla through the entertainment system, and they earned 75 grand. Not enough to actually win the car outright, but enough to go buy it if they would want one. We run this contest globally because we want to flush out these problems before they show up live in the field. We have tremendous support from the industry to make these things happen, and we follow responsible disclosure in that the defects that are found are run through the vendor before being made public. That is, when you find a disclosure and report it to ZDI, we don't call the press, we call the vendor. And then a clock starts ticking, and it'll go for, I believe it's 60 days, during which time the vendor has the opportunity to fix the problem, provide a patch, remediation, or whatever. And then, if nothing has happened, then it will be disclosed. And the people who submit to zero-day initiative get money for that. In fact, if you find a live bug in Microsoft Exchange, you will get $250,000 for reporting that to ZDI. The reason we do this, again, it's to flush them out. We're the largest source of independently discovered defects in industry, and we intend to continue to do this because we find it's the best way to, if you will, crowdsource and focus the energies of all those very clever people out there to try to make our infrastructure safer. Now, the problem is actually going to be getting worse as we go forward in time. We see increased rate of challenges as we move to especially autonomous vehicles and intelligent transport systems. We see reason to believe that the level of risk associated with these advanced cyber-enabled vehicles is going to go up. Now, I'm going to drill in on this a little bit more, but the point I want to make here is that there are two areas of risk in particular that are going to be impacting vehicles: the data and code on board and the communications networks. I'm going to blow up this chart a bit, and we'll see what happens in terms of the expected likelihood of problems. Those are the orange bars. Communications, big jump. Vehicles, significant jump. External comms, another significant problem. Human interaction will continue to go up. That's simply because the user interface is going to become unfamiliar, and we're going to have problems getting that there. We expect to see some problems in the update process, although vendors have done a good job of shutting down some of the earlier poorly architected update solutions. This is not to slam the automotive industry by any means. The threat landscape in general has been growing hugely and dynamically as long as Trend has been in business, which is now well over 30 years. Just looking at the past 2 decades, we've seen every couple of years a new wave of problems. It's spyware, it's threats to the web, it's mobile attacks, business email compromise, which, by the way, is an order of magnitude larger than ransomware. But it doesn't get the press because when somebody gets an email that directs them to send money to what turns out to be a bad link, you don't call the Times and talk about it. But if your business is shut down with ransomware, the Times will find out. The point is, the rate and pace and nature of the attacks is constantly evolving. Based on this, based on our company's 30-year experience and my length of tenure in the information security industry, I'm going to propose that the rate of discovery of CVEs in the automotive industry will grow by 50% annually if we do nothing. So, what kind of things can we do? This says 10 years from now, we'll have 10,000 of these in aggregate, and the number continues to go up. Well, there are a couple of things we can do. And what I'm going to do is lay out a roadmap that talks about how to deploy these. And I'm going to make some assumptions about which can be deployed right away and which are going to take a little bit longer to resolve. So let's start by looking at the supply chain. If you're familiar with DevOps, the SEC is too often silent, then you've seen this chart. There's tight integration between development and operations. As operations discovers problems, as users come up with enhancements, they go into the planning phase, which leads to the construction of code, which is then built into packages which are quickly run through test and release, deployed into the world, and then continue to run. This looks like a wonderful self-contained process. The reality is that it's not. Developers are clever. They know that somebody out there has already solved the particular problem they're working on. And so they make use of the work other people have done. So the expanded DevOps environment shows that while coding, developers will get open source components. I need to talk to TCP/IP. Well, I can code that up myself. I may have done that in college as part of an exercise. But the fact is there are half a dozen TCP/IP implementations on GitHub that I can pick up and use basically for free. And they've been out there for a decade or more. Hundreds of thousands of production hours with no problems. So it's safe. And we'll put it in there because we all know that open source, millions of people look at the code and examine it regularly. Similarly, in code, you use purchased applications, common subroutines to get things done. We use third-party source control, both purchased and, again, open source. We use test tools and suites that come from outside. We use version control capabilities. Why is this interesting? Well, it's interesting because when you take a look at your supply chain, you'll see that the attacks are not because a developer did something wrong, but because somebody tampered with the stuff upstream. Log4j was an impact to anybody who is using open source. What does it do? It takes data from this field and moves it to that field. And it interprets on the way over. So you don't have to put a value. You can put a pointer or a URL or anything. And Log4j will take that, decompose it, and then put the result into that field. Unfortunately, that's an easy way to get malware into your system. Ripple 20, that's the fourth of a series of vulnerabilities that impact TCP/IP stacks. There are 20 vulnerabilities that were put under this label. And here again, They were introduced when the code was written back in the early teens. They've been out there for well over a decade, and this stuff is a problem. The Nessus defect hits test tools. Kaseya and Orion, the SolarWinds attacks, hit systems management tools. Hive impacts production environments by disrupting, well, you get the point. This supply chain is wide open, and without knowing what's in there, we run the risk of introducing dependencies on stuff we know nothing about. And here's an architectural model of what that vulnerability actually looks like. If you're a fan of XKCD, and I am, this was one of his more brilliant discoveries. That random person in Nebraska who's been maintaining something for 19 years is actually a cornerstone of today's digital economy. The point is, there are tremendous and complex dependency chains. How do we fix that? Well, one thing would be to start using software bills of materials. A software bill of materials is simply a parts list. Think of it as like the ingredients on the side of a can of soup. It'll tell you what's in there. It'll tell you where it came from. And in the case of a mature SBOM, it'll tell you what level, what version, the time accessed. And so if a defect is reported in that piece of code dating back to 2003, then you'll be able to take a look at your dependency list and say, oh my gosh, we have that version. It may sound like a trivial problem, but the Equifax breach resulted from exactly this lack of awareness. They heard there was a problem in the Apache code. They looked and they couldn't find any instance where it was anything that they were running. And it turned out their scan was incomplete. So if we fix the supply chain, I'm going to posit that this cuts the defect rate, the discovery rate for new CVEs from 50 to 20%. If we do that starting next year, then we're on a curve that says we get to less than 2,500, say around 22, 2,300. We've cut the number of CVEs by almost 4/5. We want to apply this kind of technology to solve the underlying problems, but we're in firefighting mode. We have to take a look at the hottest, most pervasive problems and fix those first. So we fix the supply chain. That's step one. What do we take a look at next? Being able to figure out where your defects come from and to communicate those back upstream to your suppliers and downstream to any individuals who rely on your stuff. Think consumers who are running apps based on technology you provide. They want to know that there is a well-structured architectural approach to categorically eliminate classes of vulnerabilities as we go forward. This means that we need to instrument our technology. We need to put some kind of probes, some kind of metrics, some kind of way of gathering the alerts and telemetry from what's going on, some way to aggregate the logs being generated in these vehicles and in their associated ground stations so that we can get a comprehensive view of what is going on out there. The way to do that is through a security operations center. If we are able to bring the information together and then ship it to an XDR-capable SOC, extended detection and remediation, XDR means that you can not only identify the problems, but go after the root cause and fix them. Then we're going to be able to take that growth rate down from 20 to 10%. And now we're looking at not 2,200, but 1,600 defects in 2032, cutting the rate in half based on the successful deployments we've seen with SOCs in the real world. So we've now solved two problems. The next problem has to do with communications. And this one's going to be very big because we have a major change coming in our transport infrastructure. The introduction of intelligent transport systems is going to rely on vehicle-to-vehicle, vehicle-to-infrastructure, and infrastructure-to-infrastructure communications. And this is going to raise a vast number of new vulnerabilities. This architecture is complex. It is non-trivial, and it will cause pain as it gets rolled out. The complexity of this is hard to overestimate. This is a picture of the ITS architecture that is being used in Japan. And what we see are the people, the cars, the centers that are controlling this, what's going on the road, the sensors in bridges, and what's going on outside in the wider world. The ability to coordinate all of this information and provide a consistent picture of what's going on, the ability to isolate attacks and to identify malware as it moves through the system through lateral migration will be crucial at making this anything more than just a nest of malware. And as above, so below. This ITS architecture is being replicated inside the cars that we're building. The complexity of the infrastructure within the automobile is, again, growing vastly. We're talking about hundreds of processors on board, multiple protocols being used in these environments, tremendous number of data sources, and the requirement is we need to be able to put our arms around this complexity. We need to know where the choke points are, where the instrumentation needs to go. We need to know how to pick up the indications of compromise because, frankly, by the time the big red buzzer goes off, it's game over. And this is a problem because as we looked at the DevSecOps chart, we can also map CVEs in the automotive infrastructure against networking, against specific componentry, and the same story will happen again. Over time, this chart becomes populated with more and more CVEs. Those are points of attack, destabilizing and rendering the vehicle itself not trustworthy. So what do? We need to enhance the onboard solutions. We need to enhance the supply chain vulnerability management. We need to do a better job of logging. We need to integrate intrusion detection and prevention systems. And we need to segment the networks. Now, note that logging and network segmentation are actually components of zero trust, which is a good architectural model for how to protect the car environment. There are a couple of other things that we need to do. But the point is that our solutions now have three aspects. There's the Security Operations Center, there's improving the supply chain, and there's improving onboard security. If we bring onboard security on board, again, with that 2-year pace, we cut the rate to 5%. And now we're looking at a 2032 where we have 1,100 defects. That is a 90% reduction from where we would have been, down from 1,600 with the previous two countermeasures in place. This means putting more code into the cars. And sadly, the one thing we know that correlates with defect rate is code size. The more lines of code you add, the more problems you're likely to introduce. So we need to think about a way to increase the quality of the code we're going in there. And by the way, fixes tend to be an order of magnitude worse in terms of quality than new code. So you can imagine an environment where if the initial quality of the release is not low enough, that when you put in a fix to patch a problem, you actually introduce an additional vulnerability which has not been seen before. In the mid-1980s, there was a paper out of IBM Poughkeepsie which recommended against installing preventative maintenance for systems that had been stable for a while, because the likelihood that preventative maintenance would introduce a defect that would perturb the system was greater than the likelihood that the problem the PM was supposed to fix would ever actually show up in that particular environment. I don't like that result. It's pragmatic, but it's sad. There is a solution. We'll get to it in a couple charts. I'm going to ask the vendors to consider the portfolio of solutions they have. They need to understand and take measures on beefing up the supply chain security for the software and firmware they run. We need to introduce baseline security controls, and this means not just confidentiality, integrity, availability. I'm going to add ease of use, trustworthiness, and safety to that. It's time IT learns something from ICS. And I'd like to ask vendors to take a look at APIs. for information sharing across platforms. We expect to see more and more of that. An additional thing I'm going to ask vendors to do is to engage in responsible disclosure programs like the ZDI. Somebody finds a bug, they report it through the vendor, coordinator takes it. Eventually, the fix gets released and the public is notified. The point is that this system is something you have to manage, or you have to find somebody you trust to manage it for you. You need to be able to respond to defects and not in firefighting mode. We cannot afford that, not with the number of vehicles and the consequences of errors. So what do? We need to improve the maturity of the process. Those of you who've been through quality performance improvement, Deming and such, Duran will remember that the best way to fix a bug is not put it into the software. When I ran the build and test group for IBM Poughkeepsie, I had a simplified diagram of the software development lifecycle. It had the defect injection phase, followed by the defect detection phase. And my goal was to shrink the defect injection phase. It made finding the bugs easier. By introducing process maturity, and that means going to CMMI level 3, we're going to be able to cut the defect rate to less than 1% per year. I don't think we'll be able to do that within the next 6 years. But with that, we can view a future where we're looking at just over 1,000 defects and not rising very fast at all. I'd love it if we could get there sooner. But those of you who've worked in environments that have gone through the march from firefighting to reliance on expertise to actual documentation know that this is a learning curve, and each organization has to learn it. The supervisors and the managers and the executives have to set and sustain that tone. In the moment of crisis, you cannot adopt the firefighting mentality and throw all that out, or you will set yourself back on that 50% curve. So I'm going to end up by talking about process maturity. We want to get that curve nearly flat, and we want to get there as soon as we can. But unfortunately, we have some problems we're going to have to fix before we can make that happen. I don't see any way to improve the process of 2-year releases. I don't see any way to merge these solutions into one bundle. I'd love to talk about how that could happen. But the fact is that getting the culture right, getting rid of the vulnerabilities in the supply chain, beefing up the security on board and for communications, and establishing robust security operations center with the right APIs to communicate across the environment. If we do that and get the culture right, then we will provide a safe and fun to drive future for our users. Thank you.